So my name is Edward Servan-Schreiber. I'm Director for Solution Architecture at MongoDB, and this webinar is to present when you should use MongoDB and, in some instances, when you should not. So the agenda will be, first of all, a brief review of what MongoDB is and what is MongoDB for, and then I'll tell you what MongoDB does very well and comment on what it does less well. And then what do customers do very well with MongoDB, and sometimes what they should not try to do. I'll show you some unusual use cases, because there are the use cases we advertise, and some that we don't necessarily see very often, but that are very interesting to show the breadth of possibilities with MongoDB. And then some tick marks for selecting and helping you select MongoDB or choose MongoDB when it's appropriate. Okay, MongoDB, brief reminder, is a general purpose operational database that is document oriented, and it is open source, which means that you can download it and start using it right now. What is MongoDB for? So we aim to be the database for systems of engagement. This notion is from Geoffrey Moore and has been sort of taken up by the analysts. What does it mean? It means the systems that are able to engage on a 24/7 basis all the time on with customers, right? It is the systems that we see on all of our mobile devices and that are allowing customers to interact with brands and enterprises on a continuous basis, which means that there are very demanding real-time SLAs, a very diverse mixed set of data, massive concurrency. You have to be able to take in at times, at peak time, millions of people concurrently. It's often going to be applications that are deployed globally over multiple sites and often multiple continents. No downtime is tolerated, not even for maintenance. You want to be able to grow with user needs. This is a key point. You want to be able to make sure that you are not stuck in the constraints of a given data model. You have to be able to grow as the market evolves and as the data that you need for your application evolves. There is a high degree of uncertainty in sizing. What you start with at the beginning of your deployment is not what it's going to be after a year. There could be explosive growth, which means that you may have to grow from 1,000 users to several million users in the space of a few months. And you have to be able to deliver a seamless and consistent experience wherever you are and at any time. That's the system of engagement. What is MongoDB not for? MongoDB is not an analytical suite. We are not competing with SAS or SPSS. It is not a data warehouse technology. We're not competing with Teradata, Netida, Vertica, or Hadoop for this matter, right? These is primarily the systems of record and batch processing platforms, which we're not trying to be. It's not a BI tool. We're not trying to compete with Tableau or ClickView, which are really visualization tools and not databases. MongoDB can be in the back of this, but I'll say something about that later. It's not necessarily meant for back office transaction processing. We're not trying to compete with IBM mainframes that are sort of very, very strong for intense batch processing. On the other hand, we also don't have the same cost. It's not really meant either to be the back end of a billing system or general ledger system, which is more the purview of Oracle RAC. And is, again, tends to be for intense batch processing sequences or for things that require instant failover. And we are not a search engine, meaning that the search engines really optimize on the understanding of text and being able to build a text index that allows you to do all kinds of faceted searches, and we'll say a few more things about that. That's not necessarily MongoDB's sweet spot. What do analysts think of MongoDB? Recently, Gartner has basically made a review of all the operational databases, and MongoDB, among the NoSQL space, is the first one to make the challenger, the challenger quadrant, which means that we have a very strong ability to execute. And Forrester has made a review of the document-oriented databases and has recognized us as the leader. Where do we fit within an enterprise IT stack? So within the data management space, right, there is infrastructure at the bottom and applications at the top. Within the data management space, there is offline data, which is usually what is going to be within a data warehouse or in a data lake, as they are now called, in Hadoop, and the online data, which are really the basis for systems of engagement. And these tend to be classic relational databases or increasingly MongoDB. These two spaces are going to, this distinction we predict is going to remain at least for a while, right? What you need to do technologically as a database for analysis, for large-scale ad hoc analysis, is very different from what you need to be able to sustain for OLTP workloads. Now, I think it's fair to ask, why does MongoDB even exist? What relational databases for OLTP systems have been around for a very long time. What has happened that makes MongoDB popular in this space and challenge its dominance? Well, all kinds of things have happened in the market, right? There are now more mobile devices than there are personal computers. Social media has exploded the use of these devices and transformed what it means to run an application. Of course, the classic thing is big data. The amount of data has multiplied. And for an enterprise, what is very relevant is the fact that they now want to deploy in a very elastic manner on the cloud over commodity hardware. And classical relational databases do not really know how to scale in a distributed fashion very gracefully. Basic review of what MongoDB is, really. The advantages that MongoDB provides are, number one, agility and flexibility through the document data model. I'll say a few more things about what the document data model is, but it's really the key thing that allows you to shrink the exercise of data modeling that is sort of the classic bottleneck in a relational database deployment. It's a very high-performance database that promotes strong consistency. What you read is what was written last. We do not work on an eventual consistency basis. It is highly available, meant to be available 24/7, even through maintenance windows. You can upgrade to a new version of MongoDB and change and maintain the hardware without ever having to go down. And it is horizontally scalable. This is in contrast to vertically scalable, which is essentially another word for getting a bigger server. And horizontal scalability means adding servers in order to scale in a distributed fashion the capacity of your database. What are we really offering? On the right, you'll see a JSON document, which is sort of the native data representation that we have in MongoDB. And the important thing to notice, right, is first of all, a JSON document is a bunch of keys and values, field names and the values. And you can choose the fields that you're going to put in a document freely. You do not have to go through a DDL or a document definition step. Documents within a collection can all be very different, and you can still index any part of it. And notice here the location, which is a latitude and longitude. We also have geospatial indexing that allows us to do very efficient geospatial queries in 2 or even 3 dimensions. And a very interesting aspect here is the fact that cars here is a list. It's a list, sequence, or array. These are all synonyms, and a list of sub-documents. So you can have a hierarchical data model, and you can also have the flexibility of not having to split this in 2 tables as you would in a relational model. You would have another table for cars and some foreign key joining the owners and cars. Here, you can just put it all within the same document, and this flexibility is the number one value that has attracted developers to MongoDB in order to simplify their development. What do we offer on top of this data representation? We offer very rich queries, geospatial querying. There is a MongoDB query language that makes us feel that we can call ourselves legitimately a database. We can apply also a text index for elementary text searches. There's an aggregation framework, which allows you to do real-time analysis on the database. And there is even a MapReduce framework to do some deeper analysis, Hadoop-like, although not necessarily meant to traverse terabytes of data. It's for queries that sort of take minutes at a time rather than hours or days. The requirements to answer the challenges that have faced the OLTP relational database is really when you want to build a modern application, a Web 2.0 or Web 3.0 application on top of a database, you basically need hierarchical data structures, a dynamic schema. You cannot be stuck on a particular way to represent your data because you don't know how your application is going to evolve, and you will need to be able to change things, and you cannot go down for those things, and you cannot go through weeks of data modeling exercises in order to do this. It needs to interact very smoothly with the most object-oriented languages. It needs to scale gracefully, and it is, of course, out of the question to provision enormous deployments before you know that you are successful. So you have to scale on demand. That's the key point. You need high performance, and of course you need to make sure that you have a good TCO, a low software cost, work with data consistency to make development easier, have a rich querying language, and make it easy to use and learn. Where do databases stack up for this? Well, on a lot of these, the relational database, as you see in the first column, is actually not doing too well because that's not what it was designed for. So it's feeling a little challenge there. You see that the other NoSQL alternatives are actually doing much better. And on all the top line, this is where you're going to find the great value of NoSQL. On the other hand, you'll see that MongoDB, my claim is that MongoDB is actually good on all of these fronts and allows you to really accelerate the time to value when you're developing a modern application. As a database, from a technical perspective, from a feature perspective, where does MongoDB shine? Let me go through first what it does well. The first thing it does very well is straightforward replication. And here, there are, of course, replication technologies for other databases, but this is straightforward in the sense that it's not an add-on. It's not a costly add-on. It's not a separate software installation. It is just completely innate to the database that there will be replication. And even the initial sync, right? Just you set up a replica and you say, OK, I need to replicate from this, and it just does it. It's not at all a complicated setup. It's a classic astonishment in our trainings when we see the audience stunned that we can set up replicas in less than 10 minutes. It does very well in high performance for mixed workloads, which is interesting. I mean, it does very well for all reads and even all writes. But what's really valuable is that it does very well when you have both of them coming simultaneously to the database, which is what is going to happen. You're going to write and read at the same time. You will not be able in a modern app to separate the write load in a batch window at night and the read load during the day. It will all come at the same time. You have to scale on demand. It's the on demand that matters. Otherwise, you end up provisioning massive amounts of hardware and storage before you need it, and no one can afford that much capital expense anymore. Location-based deployment. A single cluster can span the entire globe. I'll show you an example of this later on in the presentation. Geospatial queries, which makes it very relevant for any mobile apps that wants to leverage the geography of the location of the user. High availability and automated failover. That's the key point. It's not just highly available. It means that if there is a failure of a machine, of a disk, of a data center even, it will automatically fail over to one of the replicas so that there is actually no downtime and you do not need to wake up for it. So it minimizes the stress of poor ops people who have to handle the infrastructure for these modern apps. Flexible schema, because you cannot afford to have strong years of data modeling. You have to be able to get started and then evolve as your needs evolve, as your requirements evolve. Agile development, you have to be able to work in most of the common programming languages, and you have to be able to work with agile methodologies. Commodity infrastructure. It is now increasingly intolerable for enterprises to be locked in a particular hardware vendor, and they want to be able to not only work with any kind of hardware, but even virtual hardware. A lot of our customers at MongoDB are deployed on Amazon Web Services. Real-time analytics. This is data is just data. It is not yet information. To get information from data, you need to be able to do analytics. This is, of course, why Hadoop is such a powerful proposition, but Hadoop is essentially batch analysis. If you want to get information right away from your data as it comes in, a real-time dashboard, then you have to be able to do real-time analytics, which MongoDB does very well. Text indexing for when you have elementary search needs. Data consistency, which essentially means whenever you wrote something, you can read it right away. You do not have to worry about the eventual consistency, and that makes much simpler application design and coding. And coming with our new version 2.8, for which there's already a release candidate, compression. What does MongoDB not do so well? Well, it does not do resource management. What do I mean by that? You cannot in the database say that this user is going to have be allocated these CPUs or this much RAM or this much of the IOPS of the disk. This can be done to some degree, but it has to be done at the infrastructure or OS level. It's not part of the database. And this is more usually a feature of data warehouses. Collection scanning, full table scans. When you're under load, what happens with a full table scan on Mongo is that the working set is in RAM, and if you do a full table scan, the working set is going to be quite disrupted. So if you have a strong operational workload and you're trying to do full table scans, it can disrupt things significantly. But again, collection scanning tends to be an analytical need rather than an operational need. Absolute write availability. What I mean by this is that if there are times, there are some basic trade-offs that you have to do in database design, and one of them is consistency versus availability. If you want to make sure that what you read is always the latest thing that is written, you have to make some trade-offs on availability. And essentially, Mongo privileges consistency, which means that from time to time, if there is a failure, the failover to basically be able to write again is of a few seconds. There are other designs that allow you to write all the time, continuously, but you pay with an eventually consistent model. Faceted search. It's very common for Mongo to be deployed in conjunction with a search engine because Mongo is not so good at faceted searches when you have to make searches on 20 or 30 attributes, and this is what search engines are very good for. Joins across collections. There are no joins across collections in Mongo, and in a sense, if you need that, you need to do it in the application code. People who come from relational tend to be very shocked by this. This need of joins is highly mitigated by the document model, which is why it's not nearly as much of a concern as you may expect, because as you saw in the show of what a document was, it's possible to put a lot of information that normally would be in separate tables in a single document. And of course, we do not speak SQL. There are now some partial solutions in the market that are being built in order to have sort of ODBC working with MongoDB, but it's certainly not native. And you do not have transactions over multiple documents. The transaction semantics of MongoDB are over a single document. You can make all kinds of changes to a document, and either they all happen or none happened. But if you want to have that over multiple documents, that is, at this stage, still a feature of relational databases. I would like to point out, though, that you can code this up at the application level, but it is rarely needed in our experience with good schema design. What are some classical use cases of MongoDB? This is the kind of thing you will find on our website. We do single view of anything, whether it's single view of the user, single view of the customer, single view of the product, single view of a device, single view of a manufacturing tool. Internet of Things, I'll show you an example of that. Mobile apps, real-time analytics, in order to give real-time dashboards for people who need to be able to react, where there is great value in reacting within minutes to an event. Product catalogs, we are very strong on this, and we're getting great traction in retail thanks to this. Auto, for those in the United States, is the largest catalog retailer in Europe, and they own lots of brands, including Crate & Barrel in the US. Personalization, meaning that the challenge in retail and a lot of these e-commerce sites is making sure that the experience of any individual is tailored to themselves, to each individual, which means that you have to assort essentially as many stores as there are current users. And this is the effort of personalization for which Mongo contributes tremendously well. And content management. This is when you have a lot of media, and you want to manage the metadata in order to search through them and to manage the versions and to manage all the changes and all the varied data that comes through it. So there are other use cases that we do. Here at the top of what MongoDB is good for, I repeat the same use cases that you found on the previous slide. There are also other things. Inventory management, being able to update the inventory over an entire nation or continent as the sales are going or as the supply efforts are coming through. Personalization engines, shopping cart, having a universal shopping cart that works over multiple devices. Dependent data marts, very interesting bit. Because people complain about the fact that data warehouses are too hard to extract data from, and they build data marts in order to free themselves from this constraint, and often they put it in MongoDB. Archiving for fast lookup. We see in many compliance cases, terabytes and terabytes, hundreds of terabytes of archives, and the point for them is not to do analysis on them as much as being able to look up something for a compliance request very quickly. And MongoDB is very good for that, and Craigslist has done that for all of their announcements, for all of their offers, sorry. Collaboration tools, messaging applications. What are these? Let me go into the next slide to show what this is, right? Messaging applications is essentially Twitter-like applications, and some of them are built on MongoDB. Log file aggregation. You may or may not know that Splunk actually now is able to work on top of MongoDB, and it makes the deployment much easier because of the flexibility of data representation. And caching, where you use Mongo as a cache, which is similar to the dependent data mart in order to enable massive reads. If you want to get a data set and offer it to millions of people for reads, it's not reasonable to put this to send them to the mainframe or data warehouse, but it's perfectly reasonable to do that to MongoDB. And ad serving is, of course, our history. Our founders came up with the basic designs of MongoDB when they were working at DoubleClick. Where it's not so good. So a search engine, right? We can do faster search, but with few attributes. So when there is a great majority of searches that are over a few of the attributes. So a search engine, as soon as you have very massive number of attributes and you want to do, and you have it's very hard to predict the facets that will be used, a search engine tends to be necessary. Slicing and dicing of data in unplanned ways, and the emphasis here is on unplanned. It's what you do in a data warehouse, right, where precisely the point is to be able to do analyses and joins in ways that nobody necessarily thought about before, and that tends to require, unplanned joins and full table scans. That's not what you need. That's not what MongoDB is going to be very good for. Nanosecond latency writing, right? There are algorithmic trading applications require essentially to be able to write and understand things at the nanosecond latency level. There are specialty databases for this. We are at we work at millisecond latency, but certainly not below that. If you have uptimes that are beyond 5 nines that require instant failover, MongoDB is not so good for that, because these applications require failover of, say, 1 second or less. When you have a failure in MongoDB, to be able to get the next to the failover in order to be able to resume writing, you can always read from MongoDB, but in order to resume writing, you're going to need more than 1 second. It will take a few seconds. And batch processing, that's what Hadoop is for, batch processing for big data. And they tend to be Hadoop is very strong for that. That's not MongoDB's sweet spot. I'd like to point out something that I do not list in there, which is transactions. And usually the complaint people have about MongoDB does not handle transactions over multiple documents is that to them it means, well, then you're not a good fit for financial transactions, which is not true. Because if you consider a financial transaction, it is absolutely not the case that a financial transaction requires database transactions. When you move money from account A to account B, it is not a database transaction. It is never instantaneous, and it requires actual processing because it actually, you put the request in a particular queue, which takes sometimes days to process, and this is usually happening in batch, and this is absolutely not dependent on database transactions, and some people have made these systems on MongoDB. A classic architecture that has MongoDB in the middle, right, where you have legacy systems on the left side, and then where a lot of the data from legacy sources are consolidated within MongoDB. You have a search engine next, so something like Elasticsearch or Indeka or something living next to MongoDB. And then it interacts with the data warehouse and does some operational reporting. This is a real-time analysis bit. And then there are engagement applications that are working with the data on top of it. And this is sort of a classic way to deploy MongoDB. And that means you can add data sources because you have a flexible schema, not having to go down. You can add engagement applications because then you can work with more of the data as it comes in. And you work with data warehouses, which could be a Hadoop data lake as well, in order to get the benefit of the in-depth analytics that these technologies tend to compute. But the point of an in-depth analytics, suppose you build predictive modeling to see what are the products you should propose to customers, or what are the segmentations, or whether from the analysis you can tell that these particular pieces of equipment are actually in need of repair, then these results need to go in an operational system in order to drive the operational efficiency that they promise. And where is that going to be? That is going to be with these systems of engagement based on MongoDB. So there needs to be a very close interaction between the warehouse and lake technologies and the operational technologies such as us. Let me show you some not non-obvious use cases, right? So this is a data hub for a large investment bank. This is the situation before. It was based on MySQL. And this is a reference data application, where for bank reference data is life's blood. It's basically the entities that you're trading. And all of the updates were happening in New York, and there was a batch process to replicate this across the planet in order for traders in all these locations to be able to have local access to the data. This data, mind you, is extremely expensive. You have to pay for it, and because of the delays and the complexity of getting all these processes to replicate the data across the world, it was becoming extremely expensive and wasteful, and on top of that, it was not getting there on time. So this was actually a very painful situation, mostly because there were so many moving parts. This was not just MySQL, but the replication ETL jobs were very distinct. By moving this to MongoDB, where essentially the automated replication that you have with MongoDB completely took care or replaced all the ETL jobs, made sure that essentially you only needed to purchase the information once in New York, and within seconds it was spread almost synchronously everywhere, all the way to Australia and Japan. And this gave the traders in all these locations local access to the data. They only needed to pay once for this data. And it simplified the management so much that essentially the saving was estimated to be on the range of $40 million over 5 years. Something also that is unexpected, where people doing research in the genome and proteins are using MongoDB. Now, this is a typical analysis use case, so I was intrigued by what they were actually doing. And here the point was leveraging the flexible schema by saying, okay, let's do a molecular similarity database where we're going to represent the chemical compounds with fingerprints, as you see on the right. This is called apparently a smiley representation. And here you want to be able to make searches such as, give me all the compounds that have a Tanimoto coefficient of 0.8 or more compared to this particular compound. Tanimoto coefficient is this formula below currently, and it corresponds to, I want to see all the fingerprints we have in common, right? And from this, I want to compare how close we are. And this is actually by indexing the fingerprints, you can make this extremely efficient. And for them, it was resolving a major problem of efficiency and ease of use for this use case. Again, in big data genomics, right? You have a very large base of DNA sample sequences, and you have complex metadata around it, and you have all kinds of mutations relative to reference. And you basically need to be able to retrieve all the sequences showing a particular mutation. So a very non-trivial usage a priori, but they resolve this by saying this is actually very similar to a content management system. And you're going to add a tag array in the sequence document with all the mutation names. You'll index the tag array, and then you'll make queries looking for the affected sequences. And because those queries are going to be indexed, the queries will return actually very fast. It's very easy to set up. It leverages flexible representations, gives all the details about sequences, and you can evolve as your understanding of the genome evolves. And you can scale to massive volumes. You can scale to tens and hundreds of terabytes that way. And in the IoT space, we have a customer who sells industrial vehicles, right? And there are now all kinds of sensors on these industrial vehicles, and they are no longer just selling vehicles, they're selling also data. How does that happen? All these sensors basically report data to the manufacturer through these regional hubs, right? The sensors basically each of them writes to their own shard. And so in each region basically accumulates the writes, and then these are replicated to a central hub. And the central hub does some real-time analysis, or at least near real-time analysis, and based on the entire data set, I'd like to point out that the central hub has the data from all the regional hubs, and is able to return an analysis that is now extremely useful to the customers. These are fleet managers of trucks or of tractors, and they're able to decide as the trucks are or the tractors are in the field or on the road, they're able to decide, my God, we actually need to get this guy off the road for maintenance, or what he's transporting is actually no longer needed where he's going and need to reroute him, or this tractor is actually not putting the right fertilizer in the right place. It's giving, and it allows them to actually act on this when they can, rather than figuring it out later. The real question, of course, that you're asking yourself, and presumably the question you're having on your mind if you're in this webinar, is what database do you need for your business? Now, I'd like to give you a question that is very similar sounding, right? What vehicle do you want for a race? You could use a Formula 1 car, a helicopter, a 4x4, motorcycle, a train. I could even put a plane in there. Essentially, the point is, the question has no meaning unless you actually are able to answer what you're trying to achieve. And if you go back to this slide, right, without knowing much about the kind of race, if you just tell me, well, it's going to be a race on the surface, it's not going to be in the air, it's not going to be on water, I know that